We've known about the iconic double helical structure of DNA since photo 51, which first gave us the evidence that DNA might be this spiraling helix. But we still don't understand completely how its structure changes along a single molecule. And it's a really challenging problem because this perfect spiral of DNA that changes is actually only 2 nanometers wide. And we wanted to work with industry to say, can we develop a next generation of microscopes that are able to see that on individual molecules and see how it changes? So these microscopes work by feeling instead of seeing. They take a very sharp tip and they scan it over a surface and it moves up and down, feeling the contours of that surface, like a record player feels out the grooves in a record. And that builds up a picture of what's underneath it. When we took on this project, these tips that we used to feel the surface were between 2 and 20 nanometers in size, an order of magnitude bigger than the DNA, and we're not going to be able to see it. Every time you put one of these in, it'd be hit and miss whether your experiments would work. And so we set about saying, can we make these experiments work every time? So we started working with Bruker, a major manufacturer of atomic force microscopes, microscopes capable of seeing individual molecules of DNA. And it wasn't that straightforward. We worked together for, I think, at least 7 years to get this prototype from an idea to something that we could use. But it now exists and it's being used in labs all around the world. One of the real motivations for me of working with industry was to develop a tool that didn't just work in my lab. I don't want to be the rate limiting step. I want labs all around the world to be able to use this as a tool that doesn't require 10 years of training and a lot of luck, but is something that they can just start using straight away and do new exciting science with.